Hello everyone. Today we will learn about inertia and Newton's first law of motion and Newton's third law of motion. Okay? Second law of motion I'll explain in the next class. Now what is inertia? You know that any object when it is at rest it will remain in that state of rest unless an external unbalanced force acts on it. The two words are there, external and unbalanced. Why do we say external? Suppose you are going in a car and it broke down on the way and you want to push it to the nearest workshop. You are sitting inside the car. Sitting inside the car, if you start pushing the car, will the car move? You know, it will not move. Because you are a part of that system. Car and you form a single system. And you are sitting inside the car. So the car will not move if you push it from inside. Whereas if you get down from the car and push it from the back, you can move it easily. And that is external force. From outside you are pushing. So if an object has to move, the force has to come from external. External force has to act on it to make it move when it is at rest. And if there are more than one force, you know that, look at this. Now, if I apply force from both the sides, which are equal and in the opposite direction, this will not move. There are more than one force acting on it, but they are balanced forces. They are equal and opposite. So they get cancelled. So you call it balanced forces. More than two forces, if you have on this side and only one force acting from this side, but you find that it is not moving if the sum of the two forces acting on one side is equal to the single force, then again they are getting cancelled. Here also it is in the balanced state, though there are two forces from one side. Understanding? The sum of these two forces will be equal to the single force, which is in the opposite direction. So, the forces acting should be unbalanced to make it move. Okay? And similarly, an object which is in motion will continue to move again unless an external force acts on it. So, remember, when there is no friction, you find that a rolling object will continue to roll unless an external force acts on it. That's what inertia is. Okay? Its tendency to move. It is from that Newton formulated the first law of motion, saying that every body continues to be in the state of rest or of uniform motion unless an external force acts on it. Is that clear? So that is the first law of motion. Now, when you come to the third law of motion, you talk about action and reaction. See, when you learnt about normal force, you learned that when an object is placed on a table, the weight of it acts in the downward direction and the tabletop or the surface exerts an equal force in the opposite direction, the upward direction. So the forces are getting cancelled there and the object is not moving. So you say acceleration is not produced. Acceleration is equal to 0 since it is at rest. So you know that weight acting downward will be equal to the upward force, normal force, since there is no acceleration. Is it clear? But here, the normal force, I said on the first day when I explained about normal force, I said normal force is not that action reaction which comes in the third law of motion. In the third law of motion, you feel it is very easy to understand action and reaction. They are equal and opposite. That's what you think. Yes, it is true. But remember, they both act at the same time. It is not that action happens first and then reaction comes after some time. It's not like that. They both act at a time, simultaneously. So you say that Newton actually said forces come in pairs, that forces occur in pairs. That means action and reaction occur as pairs, but they act simultaneously. Okay, not one after the other. And the other main point, and that is action and reaction are acting on two different objects, not on the same object. Therefore, they do not get cancelled. These are the main points you've got to learn in the Newton's third law of motion, which says that for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction, but acting at a time. Okay, forces occur in pairs and they are equal and opposite. That's why you feel they might get cancelled, but it will not get cancelled because they are acting on two different objects. See, with this hand I am applying force on the other hand. With left hand you apply force on the right hand, and with the right hand you apply force on the left hand. So forces are exerted on two different hands. They will not get cancelled. Understand? That's what happens when you can see it very clearly when two balls collide or two objects collide with each other. The force exerted by one object will be equal to the force exerted by the other object on each other. Okay? The forces will be equal. But the effect of that, you see, as the acceleration produced in it will be different. Suppose you take a heavy object and a ball or something like that which is lighter. A heavier one and a lighter one you take and you make them roll to collide each other. You find that the lighter one will be accelerated, isn't it? You will find it moving with a greater speed. The other one will not be moving with that high speed after collision. That is because of the difference in their masses. Understanding? That's why you find that when accidents take place, when a cyclist go and hit against a truck, nothing happens to the truck because of its mass. But it is going to affect the cyclist. Cycle is not having that much of mass, so it will be thrown off after the collision. Understand what I am saying? So remember, Newton's third law says that for every action there is an equal and opposite reaction. But remember, forces come in pairs, they occur in pairs, and your action and reaction are acting at the same time simultaneously on two different objects. Though they are opposite and equal, they are not getting cancelled because they are acting on two different objects. Here, when you learnt about normal force, you learn that the weight is getting cancelled there with the normal force. What is the reason? They are equal and opposite, but they are not action-reaction, I said. What is the reason? What is weight actually? it is a pull of the earth on this object. So the earth is exerting force on this object. And what is normal? The surface is exerting force again on this object. So the two forces are acting on the same object but in opposite direction. They get cancelled. That's why we say the normal force is not the reaction force as you learn in Newton's third law. Is it clear?